Next we will talk about multiplying polynomials. Remember this exponent rule. X to the a times x to the b is equal to x to the a plus b. So if I have x squared times x to the fourth, notice the variable x has to be the same and the variable x stays the same in the rule. In the rule we have the exponents adding, so 2 plus 4 gets me 6. So x squared times x to the 4 is x to the 6. X times x is a little tricky, but you have to remember that there's invisible exponents of 1. So when I multiply x times x, the bases have to be the same, and the exponents are added, so 1 plus 1 is 2. On our next problem, we have coefficients as well. So 4 times 7 is not applied by our exponent rule. 4 times 7 has always been 28, and it still is 28. What we use the exponent rule is for the exponents. So x to the invisible 1 and x to the 3. When I multiply those two, I'm getting x stays the same. I add the exponents. There's an invisible 1 plus a 3. That gets me 4. So I get a result of 28x to the 4. On our next problem, 4a squared b times negative a to the 4th b to the 7th, I multiply my coefficients. My coefficients are positive 4 times a negative 1. So go ahead and put a 1 there to help you remember that it's together. So that coefficients just multiply and I get me negative 4. Now let's do the a's. I have a squared and a to the 4th. Notice the bases are the same, so I keep the base the same and I add the exponents. 2 plus 4 is 6. And now let's go do the b's. B to the invisible 1 times b to the 7. The base is the same, so it stays the same b. And then I add the exponents. 7 plus 1 is 8. Next, remember the distributive property. So I have a times the b plus c gets me a times b, the first term, plus a times c, the second term. This is the distributive property. So when we multiply polynomials, you need to use the distributive property to get rid of any parentheses, and then I want you to combine like terms. So on our first problem, we have 2x times 3x minus 4, so I'm going to distribute that, minus 6 times 2x plus 1. So then I'll just take the negative 6 and distribute that as well. I'll use two different colors to help. So I have 2x is being multiplied by 3x. That gets me 6x squared because the little invisible ones add. 2x times 4 is negative 8x. On the next one, I have negative 6 times 2. That's negative 12x. And negative 6 times positive 1 is negative 6. At this point, I'm going to look for like terms, and I'm going to add them. It looks like 6x squared doesn't have any other terms like it, but the two middle ones, negative 8x and negative 12x, do have like terms because they both have the same variable part x. So that means I'm going to add their coefficients to get negative 20 and keep the variable part the same. And then minus 6 doesn't have any common factors either. So that's my final answer. On my next problem, I have 2x squared times 3x squared minus 4x plus 1. So I'm going to distribute the 2x squared to every single term inside the parentheses. 2 times 3 gets me 6. X squared times x squared is x to the 4. The base stays the same, the exponents get added. 2x squared times negative 4x. The 2 times negative 4 is negative 8. I multiply those whole numbers or coefficients just like I've multiplied them always. Then we have x squared times x. Don't forget that x has an invisible exponent of 1. So I add the exponents to get a total of 3. Plus 2x squared times 1, well, that's just 2x squared. Notice none of these terms are like terms. They all have the same base, but all of the exponents are different. So none of these can add because they're not like terms. On the next problem, we have a binomial times a binomial. 2x minus 3y times the quantity x minus 4y. So the 2x needs to multiply to both terms in the second parentheses. And then the negative 3y is going to multiply to both terms in the second parentheses. Some teachers call this FOIL. I like to call it double distribute. I'm taking the green 2x and I'm distributing that to get 2x squared minus 8xy. When I multiply, I'm taking the coefficients and multiplying them and adding any common exponents for common bases. When I distribute the 3y, the negative 3y, don't forget that the negative is always attached to the term behind it. So the negative goes with the 3y. Negative 3y times x, those are not like terms, so I just put them x and y together, negative 3xy. Now some students prefer to write negative y, x, because they see the y first and then the x. I prefer to put these in alphabetical order, just so that later you can see that these are like terms. Either way should be fine, but I find it if you do it this way, putting in alpha order, then you're going to have less mistakes on the next step. On the last distribute, I have negative 3y times negative 4y. Negative 3 times negative 4 is positive 12. Y to the invisible 1 times y to the invisible 1, that's y squared. Now when I add like terms, the 2x squared doesn't have any like terms, and neither does the last one, 12y squared. But the ones in the middle, the negative 8xy and negative 3xy, add together because they both have a common xy. Negative 8 minus 3 is negative 11. Keep your xy. Our next problem is similar. It's a binomial times a binomial. So I'm going to distribute the 3x cubed to both terms in the second parentheses, to the 2x cubed minus 1. That gets me 8x to the 6 minus 4x cubed. Next, I'll take the positive 5 and distribute the positive 5. 5 times 2 is 10x cubed. 5 times negative 1 is negative 5. Now I look at all four terms. 8x to the 6 does not have any like terms, so he comes down. The next one, I have negative 4x cubed and 10x cubed. Notice that the x cubed variable part is the same on both of those, so I add them and get 6, positive 6x cubed. The variable part stays the same when you're adding. And then the last one, minus 5, doesn't have any common or like terms, so that just comes down. Again, I have 6x minus 5 times 6x plus 5. I'm going to distribute the 6x to both terms in the second parentheses to get 36x squared plus 30x. Then I come back and grab the negative 5 and distribute that as well. Negative 5 times 6x is negative 30x. Negative 5 times positive 5 is negative 25. 36x squared does not have any like terms. The two middle ones, 30x minus 30x, add to 0. Now, writing 0x is a little redundant, so normally we don't actually write 0x because I don't write what I don't have. I don't have any x's, so let's just not bother writing them. One way of thinking that is they add to 0, so you don't have to write it. And then the minus 25 doesn't have any like terms, so that comes down as well. On the next problem, I have a plus 5 times a squared plus 2a minus 3. So the first term, a, needs to distribute all the way through. So that gets me a cubed plus 2a squared plus 3a. So that's my first distribute. My second distribute is the 5, so it distributes to all three. So that gets me plus 5a squared. 5 times 2 is 10a. 5 times 3 is 15. So notice I have 1, 2, 3, 4, 5, 6 total terms there. Now that's a lot of terms, so be a little bit careful. I like to underline as I go to make sure that I've gotten all of my terms and I haven't missed one, especially when they have lots of them. A cubed doesn't have any like terms, so I'm going to go ahead and write that down first. Next I have a squared. I have 2a squared and 5a squared. Add those two together to get 7. Keep the variable part a squared the same. Next I'm looking for a's. I have a 3a and a 10a. Add the coefficients to get 13. Keep the variable part the same. And then plus 15, the constant term, that doesn't have any like terms, so it just comes down. Notice that all of my 6 terms on the previous line are now all underlined, so I've made sure I've gotten them all. This next problem doesn't quite look like any of the others because it has x minus 4 quantity squared. Well, quantity squared just means x minus 4 times itself x minus 4. If you write it out like this, then it does look like all the other ones we've been working on. So we have x times x. I'm going to distribute the x squared minus 4x. And then I'm going to come back and grab the negative 4 and distribute that as well. That's why I call it double distribute, because you distribute the first term and then you come back and distribute the second term. Negative 4x times x is negative 4x. Negative 4 times negative 4 is positive 16. Okay, so the x squared doesn't have any like terms. Minus 4x, those are like terms. Now, minus 4 does not add to 0. Negative 4 minus 4 is negative 8. Notice the difference between this and the one above it. The one above it we had positive 30x, minus 30x, and because they're opposite signs, they did add to 0. But because negative 4x and negative 4x are the same signs, they add up and keep their sign negative. So we have negative 8. And then 16 doesn't have any like terms, so that comes down as well. So the last one of this type is 3x minus 4y times 2x plus y. Notice we have both variables x and y here. So we'll distribute and get 6x squared. Notice the x times x, because they have an invisible exponent of 1, they add up, plus 3xy. Come back and take the negative 4 and distribute that as well to get negative 8xy. Some students want to write yx, which is fine, but you need to understand that xy and yx are like terms, and that confuses a lot of students. So instead, I would prefer to put xy in alphabetical order. And in our last term, negative 4y times y is negative 4, because you're multiplying the coefficients. Y times y is y squared. The first term, 6x squared, doesn't have any like terms. That just comes down. The two middle terms are like terms, so I add them up and get negative 5, because positive 3 minus 8 is negative 5. The variable part xy stays the same. And then negative 4y squared also stays the same. Now there are some common student errors that pop up here. Sometimes students will confuse the addition and the multiplication rules for polynomials. So just let me clarify one more time so you can see the two processes right next to each other. When you're adding polynomials, I want you to add the coefficients and keep the common exponents the same. But when you multiply polynomials, I want you to multiply the coefficients, but add the exponents. And it's really these two that they get confused, what to do with the exponents. Usually they get the coefficients right. So let's practice these real quick. 6x plus 7x, because I'm adding, I add the two coefficients to get 13, keep the common exponent the same. So x to the invisible 1 stays the same. But when I multiply 6x times 7x, notice these are the same two terms, I'm just multiplying this time. I multiply my coefficients to get 42, and I add my exponents. X times x is actually x squared. Add 1 plus 1 to get 2. Let's do it again. 5p to the 4th minus 8p to the 4th. Are the p to the fourth variables the same? Yes, they are. That means they're like terms. So I want to add or subtract the coefficients. In this case, 5 minus 8 is negative 3. And then what do you do with the p to the fourth? You keep it the same. Notice on the other side, I have 5p to the fourth times negative 8p to the fourth. Coefficients, positive 5 times negative 8, multiply them and get negative 40. Take the p to the fourth times p to the fourth, the exponents, add together and get p to the 8th. All right, last example. Y cubed plus 8y cubed. Notice that the y cubed is the same for both. That means they are like terms. I'm going to add the coefficients. Don't forget that there's a leading coefficient of 1 here. So that's 1y cubed plus 8y cubed. 1 plus 8 is 9. The y cubed stays the same. But when you're multiplying those same two terms, you take the 8 times 1 and multiply them and get 8. Y cubed times y cubed. I add the exponents to get y to the 6. So I hope that little chart helps you out on making sure you know which one you're doing, if you're adding the polynomials or if you're multiplying, and what to do.